Welcome everyone, and thank you particularly to Marcus for hosting us, and thank you to Cameron Purdy for the exciting insight into an entirely different VM from the one that I'm going to be talking about now. So my name is Claes Redestad. I work as a performance engineer at the Oracle Java Platform Group. I'm here today to talk in particular about a small startup-oriented feature called Heap Archiving. So before we drop into that, we're gonna outline what JVM Startup is about, why we care, go into the class data sharing feature that the Heap Archiving is built upon, then talk about Heap Archiving itself and what's good with it and what's wrong with it. And then I'm going to ask you for help in fixing the things that are wrong with it. Right. So JVM Startup, well, when it comes to performance of the JVM or OpenJDK in general, there are many different performance concerns. The foremost performance concern is throughput. It's been the thing we have been optimizing for decades now. And then we have latency. We want our garbage collectors to be as fast as possible. We want our pause times of save points, etc. Robin Ian is going to be talking about handshakes and what we're doing to reduce latency around save points for the benefit of ZGC and stuff as such. But the general concept is, there's also footprint and startup, and people have been talking about those for the last couple of years, almost to non-stop. And it's always been one of the things that are the least important thing, at least has been, and because everything is a trade-off. Startup is what is startup. It's kind of like you start up your VM and the VM goes into interpreter mode and then it starts executing code and you JIT code. Everything costs memory and all that. And it's kind of like, yeah, we we know it's a cost and we want to minimize it as much as possible, but it should never be at the behalf or antagonize throughput and latency efforts. Still, startup is important. We want to have good quality of life for our developers and our operations service engineers or our customers if you're running Java on a desktop, etc. So we do want to improve startups as much as possible, and we've been quite successful at that endeavor over the last couple of years. In this graph, we see the out-of-the-box startup time for Hello World on a OpenJDK going from 8 throughout the releases to 14. And, well, sorry? 9, oh yeah, I've been talking about that before, and 9 hit us with the module system, which, among other things, added some small startup time or startup overhead. So the module system itself means that we execute more code during Bootstrap. So what happens then? We execute more Java code, we trigger more JIT compilations, and that kind of, it adds up to a few extra milliseconds on Bootstrap. But yeah, we kind of improved on that. One of the ways we improved on that is what I'm going to be talking about later, which means we can take a little bit of the metadata that we create during module setup, and we can archive that. But anyway, the whys is generally, we want to make Java more fun to use. We want to make everyone's experience of running on the OpenJDK less of a hurdle for developers and such. We also want to, move towards enabling these short-lived apps and stuff. And even though there might be other alternatives that might get you even further down into the single-digit millisecond times, and everything I'm going to be talking about here is startup and running on a full JVM, which does come with a number of trade-offs. But sorry, my voice is a little bit weird. Sorry. But anyway, all this progress has been at no expense of throughput and latency, as far as we are, convinced. So, how do we go about improving startup in general? The idea is to execute less code during Bootstrap, and less code during the Bootstrap of your full application. And then we need to do that. We would have to, improve laziness of constructs. We could do more ahead of time calculations of objects that you are setting up during your early execution and such things. As a second general optimization idea is you want to speed up the class loading. You're loading hundreds or thousands or tens of thousands of classes, and all those operations go to disk or whatever. You need to parse bytecode from disk, and you put that into metadata structures in your VM, and you need to verify the bytecode and various things that accumulate to quite substantial overhead. More esoterically, we would like to produce smaller binaries so that the physical or static footprint of mapping your binaries and class archives and such into memory is faster also for a cold start. And then fourth, which is the hardest one maybe, is to execute your code, the code that you do have to run, execute it faster. We've been quite successful at most of these, using lots of various different techniques. One way to make your code execute faster is to optimize the compiler itself, so that it executes with less CPU resources. And the other one, of course, is to compile code ahead of time into a compile cache, or using the AUTC tool. Or even further in the Graal VM project to go ahead and do a full native compilation. Not going to drop into any of those techniques in this talk, though. What I'm going to talk about is deriving on class data sharing. Class data sharing was introduced a long time ago as a means to speed up client and desktop Java runtime environments. So then in 8U40 it was extended to support any server collector, and it was done so to support the application CDS feature, which was this commercial feature at the time driven by Oracle engineering. App CDS is quite cool and is open source from Java 11, I think. Anyway, so class data sharing has been around for a while. And the general idea is to prime your installation of or your runtime environment using a dump step, which takes some text file which lists the classes that we should include in the archive. We dump that into a file inside the JRE called zip something, depends on what system you're on, and this file will then be picked up, mapped into your process memory on every subsequent Java execution. The effect of this is to roughly have cut the JVM bootstrap time in half. In this example of Hello World on the, I think, latest JDK for me, then the enabling of CDS cuts my bootstrap time from around 80 milliseconds to just below 40. Sorry? Hello date. Oh. You want to load all the local stuff and such. Yeah. The battery is getting... The battery in this thing is dying, but it seems to be good. Anyway, so CDS was enabled by default in Java 12. If you're on an earlier release, you might want to prime your installation with the xshare dump trick, which gets the startup curve a little bit more down to size. But since 12 and onwards, the intent is that CDS will be primed on all installations by default, which is nice. Less things to worry about and tune up. You can also, of course, deploy application CDS or dynamic CDS. There are two different things with a little bit different incantations. Dynamic CDS is a little bit easier. App CDS so far might give you a little bit of a startup edge compared to dynamic CDS, but yeah, anyway, that allows this general optimization to scale up to probably cutting your startup times on real applications by 30 to 50% or so. Anyway, the thing I've been I've been working on a little bit, even though I'm not the implementer for the runtime part here. She's now at Google and one of Zhang Li, but the Jep that started the whole heap archiving thing was an idea to put all intern strings, the string table, into the CDS archive in Java 9. The feature introduced the concepts of archive spaces that can be mapped into a VM heap region. It was since it's kind of tied to the region concept. It was only and is still only implemented in the G1 garbage collector. I can't tell, or I don't know actually whether or not it's implemented on the Shenandoah GC, but it could theoretically be because it's also a region-based, a little bit G1 derivative GC. But anyway, the archive spaces for intern string introduced in Java 9 basically allowed us to store the object representation for these intern strings in the archive. This means that if you're running many processes, you don't have to put that memory on the live heap. You can just map that memory in, and you get a small reduction in process footprint if you run many processes on a single system, which is nice. But it was pretty neutral for real startup, since these strings are, you're basically reading memory from one place or another, so it doesn't majorly affect startup in itself. But yeah, it's a quite simple model. You have a space in the CDS archive. You map that as a region in your in your heap, and you treat that region as a pinned region, which means that objects reminded to self not to drink alcohol the day before I talk. Right. I see Cameron smiling. Anyway, so right, the pinned region means that objects restored from the archive into a pinned region are not moving about by the garbage collector, which means that we can be sure that pointers around from pointers to objects within the CDS archive, within the archive region, will not be moving around. So once you bootstrap and map the area, the addresses therein will not be subject to change. You don't have to track objects where they move around, all that complexity, which is pretty nice. It's a very straightforward mapping technique. So mapping these strings, when you load a class, you have a constant string that you map into an archive. It's basically just finding the pointer in the archive and updating the constant pool entry, and kind of like that's what CDS is all about. You take the class files, you pre-parse everything, build up the structure that the VM would build for those classes, and map that into your process. So it's all about doing the work to set everything up according to your. Oh, Kirk, you have a question now? Yeah.
Are they taking that from tenured or reserved?
Tenure reserved. Are you taking the? No,
Reserved.
I don't know the answer to that question. I'm sorry.
So
There are GC engineers in the room that can probably answer the question.
no G1, but it's okay.
No. Okay. Anyway, so moving from this to general heap archiving is quite a trivial step in many ways. So there was no JEP file to go from just supporting archived strings to supporting any object whatsoever, which means the extension to JEP 250 to support any kind of objects is, on the face of it, is quite simple. So you just have to, rather than patching the LDC instruction in your bytecode, you kind of have to have a you just have to introduce one single little API link to be able to link your objects into objects on the archived region. There was a little bit of some work done to split them into open and closed regions. So, but that's not really too important. Open regions, anyway. So the first big change to actually do anything with this was 82.0.2035, which I should have written the name of rather than the bug number. But we introduced an internal API hook and the mechanism for archiving the module graph, all the invariant parts of the module graph into this archive. This allowed us to remove a significant chunk of what went into the regression for JDK 9 with regards to startup, and kind of remove that away, because we can now take all the immutable and invariant data from that graph, put that in the archive, and then just link it in when bootstrapping, which is pretty nice. And then we built on to that and found, there are lots of different things that we are doing very early in Bootstrap that could be reified into the archive. So we kept piling on various things, all the box caches, for example. There are some invariant data structures set up to support jar file attributes and base locales and various different things. And then kind of when you start pulling at these threads, you find a number of things, like if we're using the immutable collections in the archived module graph, we realized we kind of need to put most of the constants that we have in these classes also into the archive, so that we can make sure that there is only one instance of every constant. So it kind of, when you start peeling off and like, can we put this in the archive? We also kind of need to put other things in the archive. Otherwise, you would end up with two different instances, because the object in the archive wouldn't otherwise not match the thing that you are creating in a static initializer somewhere else, which would be funky, because then all of a sudden my set off wouldn't be the same instance that the other guys set off, whatever. But yeah, we do have here an embryo, or maybe a good start for what can be put into the archive, and we'll see what that adds up to later. But all in all, with strings and everything attached, we're a little bit below 830 kilobytes of memory. On the VM end of things, as someone who's using this feature or using it to add more things into, then we still do have to add a little thing into the VM implementation to hook up a certain field to an archivable archivable reference. So we do that by adding, a very simple line to a very simple data structure in one single place in the hotspot code. But it's, to some people, that's one little thing you have to add to the VM too much. So we'll think about ways to get rid of this. But let's do an experiment. I wanted to see, what's the accumulated effect of disabling the current archiving from the VM today. So I just implement into the implementation for VM initialize from archive and commented out whatever it's doing down in the VM and see what's the negative effect on startup. And we do see that, well, in the left-hand experiment, we increase our startup time from 37 milliseconds to 42 or so, which isn't that much actually. I was surprised when I ran this again based on the numbers we got when we did the initial things for this in Java 12. We were cutting away, tens, almost 15 milliseconds with the modular archiving. But it turns out we've improved so many other things that the effect is now not as large in magnitude as we as it was when we initially archived these things. If we go into looking at details, though, what's happening underneath, we see that we still have quite substantial gains with regards to the reduction in CPU use. Since one of the cool things with what happens when you archive away code that would otherwise have to run through some big static initializers and execute a lot of code is that there's a lot of JIT activity that just disappears. The system drops, even though we only gain 4 milliseconds, which is roughly 9% or 11%. We improve more substantially on a lot of other metrics when we look at CPU utilization. We also see that the number of classes we load drop down with the use of this feature, since we are avoiding the execution of certain or loading and execution of certain static initializers. We can remove the need to load certain classes altogether, which reduces footprint and has other nice pylon effects. So the pros do turn out that we are executing less code. We are removing the need to load classes. We see fewer JIT compilations. But we also see a lot of cons or annoyances add up. We do get increased coupling between JDK core library and the VM implementation. We are reliant, for now at least, to prove that the things that we put in the archive are invariant, but from run to run, and at least have a way to detect that if it's not invariant. For example, the module configuration can change by putting some VM flags or whatever. That there's a surefire way to disable the load from the archive, or simply not care about it. So, which turns into some general feeling of fragility, because what's invariant today might not be tomorrow. How do we make sure that there are sufficient testing put in place to make sure that we are not running into any problems in the future? And it's for now it's only available for JDK internals. So why am I here talking about this? Because if you have snapshotting or archiving into a CDS archive, you would kind of want to ask the question: how do you get this into app CDS and be able to archive more stuff into your archives ahead of time, and get to that kind of full-on snapshotting thing? Well, we probably need to solve a few more fundamental issues first, but we'll get to that later. And it kind of ties into the fact that we're still tied, and the implementation is quite tied to G1 and the archive region, and maybe we maybe by solving for one of the issues, we can solve them both. How are we for time? 20 minutes? Oh, I talked too fast then. No. Right. Let's skip this one. So I talked a little bit about pros and cons, and let's go into the things that we want to improve or do in the future. And well, high up on the list is of course the want to support CDS on support shared heaping on non-G1 garbage collectors. And then there's a laundry list of small improvements that we can add more things into the archive. Add a few structures that mean that we wouldn't have to load and execute various things ahead of time, so that you simply get rid of fractions of milliseconds for each one of these little improvements. I'm sure we could chip away at this for a few years, which would be fun, but would be also fun to have some ways to do it a little bit more automated. Then, yeah, I mean, CDS is evolving in various other directions too. We want to look at, and there's an implementation to archive lambda proxy classes into CDS archive, which could get rid of tens of milliseconds on slightly larger applications. But that's slightly of a tangent to heap archiving. I did prepare some examples of code that could be easily massaged into something that is archivable. But when you do take some code like this, and that is run or exists in the bootstrap path, you find that there are some problems here, because we're creating this hash map of platform and application class loaders, and mapping from your module name to another, and this is just icky and very straightforward code. But the thing is, your class loaders are probably not something you would want to put in an archive, so we couldn't just take this code and take the result of it and put it in an archive. But if we changed it around a little bit so that we're not archiving the class loaders themselves, but maybe just some integer marker or some enum value, we could archive that thing and make sure that the mapper is now ready for archiving. So I do have this patch ready to go, and I'm more or less convinced Alan Bateman that it's a reasonable incremental addition. But well, what's the effect of it? If you run this through run the hello world and look at all the bytecode that you're executing, it turns out that the little thing over on the right-hand side, about 25,000 bytecode executed to set up that hash map, we could get rid of that. It totally disappears from view, because we don't have to execute the thing anymore with the code that we have now. Since we're archiving the thing, we don't have to create all those hash maps and create the sets of modules that are in the boot class loader, which are in the platform class loader. So all that stuff just goes away. It's in a small structure now in the archive. So we do get a 3% such reduction of how much code we need to run through on Bootstrap, which doesn't add up to that much in reality, but at least about a percentage or so on cycles, about a percentage or so on branch misses, which is nice. But this also quite vividly demonstrates the problem you have when you're taking little things, improving, certain thing that you do on startup. It's like, it's not gonna add up to much in and of its, for every incremental thing you do. But you just have to make sure to have a benchmark suit or methodology where you can prove that at least it's a step in the right direction, and then hopefully you can add up 10, 20, or 100 such optimization into something that is measurable and noticeable in the end. So, but yeah, the question is always there in the back of the head: is like, are these improvements good enough for the cost of fiddling around with the bootstrap path and annoying or both core libs developers and runtime developers with the little unpleasantries that are going on to support this feature? Open question, but we can at least contemplate ways to clean up some of the technical debt that we have incurred on ourselves by, for example, considering should we add more some kind of annotation-driven system to point out that this field is actually archived, so here be dragons. So let's put in some archive annotation or something. Maybe make sure that we are using real finals rather than stable hacks, which no one outside of the room here knows anything about, and things like that. So maybe there are ways that we can just make this a little bit more hygienic as it currently is implemented in the OpenJDK. And maybe we can get rid of the need to do a VM initialize from archive altogether. Just initial by this, and then maybe something else. But when it comes to moving towards support for any garbage collector, you kind of run into a little bit of other problems that are more fundamental in the design. And one of those is that since the design kind of relies on archived and pinned regions being pinned, so that objects that you restore from the archive are not moved around, that comes into a few problems, because if you're incrementally restoring one data structure, then garbage collection happens and the thing is moved around, and then you load some other class that wants to restore some other other graph, and that one had pointers into the thing that you restored previously, then whoa, what happens? You then need to either put some implementation to track everything that is restored and where did it move. That makes the feature that much more expensive. So yeah, it might not be very easy to make this work more generically, but there might be a few at least explorable ideas. One of them would be to coarsen the granularity of restoration to complete clusters of objects, so that you can have independent snapshots that you can restore of object graphs. Such a cluster of independent objects could then be made sure to be only have pointers within the cluster, and you make sure that if you're restoring it, you'll restore it in full, during with nothing. But who knows? That would solve some issues, maybe bring up some others, and something like it would probably be necessary, but perhaps not sufficient to support user-provided data in archives. So that if we would want to extend this current implementation into something that is usable through AppCDS and through real like pre-configuration of your application, then we would probably have to solve both problems at least, and then perhaps there are some other issues that we yet haven't thought of that we would have to also overcome to make it feasible for custom generic data. Anyway, just to recap, startup performance has been going better, and careful use of heap archiving for internals only has enabled us to keep chugging away at the startup performance for the default configuration. Mind you that G1 is now the fastest garbage collector for startup, thanks to the in part thanks to the heap archiving improvements. And yeah, it's an open question how we should move ahead with this into making it into something that would be usable for everyone in a way that could keep on not only having the bootstrap time, but maybe getting those bootstrap times down into the low milliseconds.
We're moving into the
Fika break.
So great, good timing there. Catch-up questions.
Catchup. Kirk has a question. Give him a microphone.
So we were looking at this in terms of startup time for. We're not turning it on, Jim.
Just hold the clip.
Okay, there we go. How's that?
Now we hear you.
As if you had trouble before, right?
Oh, yeah, but the stream hears you too.
Yes. So we're looking at startup time for like Spark clusters as an example, and so I guess one of the questions I have about the numbers that are always being produced is like, are you talking about cold cache, warm cache start? Because most of the startup times we find are going to be dominated by disk activity. As a matter of fact, everything that you're talking about down in the milliseconds is pretty much a wash as soon as you touch disk. It's sort of, these things become quite meaningless as soon as you touch disk for any significant amount. So when we're benching all this, we made sure that we're looking at like cold cache starts always. So I'm just wondering, like, since those numbers look kind of suspiciously low, I'm just wondering, if you'd taken care of caching concerns as part of the number.
So yeah, and measuring cold startup is significantly harder in the way that I mean it's harder in the sense that you need to clear caches, but then you don't know if your disk cache, you can clear OS caches, but there are multiple levels of caching going on. So you need to be very careful on how to set up such experiments. And generally, like CDS as a technology, it adds a 12 megabyte archive by default. So if you're really, if you're always going to have to read that into memory every time, then it's kind of like a little bit of on the negative. But since most of the time those 12 megabytes will be mapped in by some of the VMs running on the system, hopefully, or that would be amortized very early in a shared setup if you are running on. So yeah, in the perfectly cold case, there are trade-offs where CDS might not be the best choice, or any kind of AUTing, etc. would be kind of negative in many cases. Even JOTC, which produces quite big binaries, might be negative to a cold startup. Not?
No, actually with J, that actually gives some very positive responses, but of course then you take a throughput hit.
Right, yeah.
Later on. So there's always seems to be this throughput hit versus right versus startup time problem that you're facing. And the other thing is the JOTC seems slightly broken because as soon as you hit the C2, you get automatic deops for whatever reason, I don't know, which means you're basically lost the ahead of time compilation bang because you need to drop all the way back down to level 0 before you can start climbing back up, through the tiers again.
Right.
So that's a loss also.
Yeah. There's a question at the back.
Hi, Robin again. I just want to mention the cold archive. We're having a thesis work in the Stockholm office, which is looking at the cold archive
Right.
to make it hot before he launch your VM. I'm not sure what he's gonna do, but he's looking into that.
We just capture everything in virtual disk.
Yeah.
Right.
Okay.
Yes, one more question is on the coffee break. Should